Good afternoon, ladies and gentlemen. My name is Mark Regini. I'm currently a student with Career Foundry. Today we are going to be answering some interview questions for Task 5.7, Part 2. So, to start things off, what does CRISP DM methodology for data mining entail, and what does the analyst do for each step? So essentially what CRISP DM methodology is a set of steps that one goes through as an analyst when do data mining for big data. It's split up into 6 steps, the first step being business understanding, gathering an understanding of what the company or who you're doing the analysis for requires out of the data. What's the final product that we're looking for? The next step would be data understanding. That's gathering the big data or the data sample that you have, looking through it, kind of checking out for quality issues, biases, missing values, things of that nature. And most importantly, you want to record these observations. Make sure that you write down every step of the way what you're doing, what you change, what you observe. Like I said, any biases that you may think could be present in the data, just so you make sure that you cover all your bases and you're very transparent if another analyst were to look at your work. The third step would be data preparation. That's where you go through the data and you clean out all of your duplicates. You select what data is going to be prevalent and which data is not necessary for your analysis. Clean the data, remove the duplicates, make sure formatting's correct for all of the different variables and all the records. And sometimes this may mean actually deriving some data. Say you have a sales and you have a time frame, but you want to know, sales per hour or something of that nature. Deriving another column to create those variables is part of this step as well. The fourth step would be modeling. This is where you're applying any necessary algorithms or are also called models to your observations. So you decide what kind of model you want to use for it. Designing a test for that model to make sure that it is efficient and does accomplish the task or the business requirement that is needed from you. And then you design a prototypical model in order to test the efficacy of that model, of that algorithm. Recording any testing stages that you go through, any results that you find. Evaluation is the fifth step. That is where you kind of assess whether the model meets the business goal that you were given in the first place. This is actually the last point in which you can kind of check for any errors, any inconsistencies, any misoutputs from your model. That way you can have a complete understanding of the model and you're good to go, and it's a solid model to deploy. Which leads us to step 6 is deployment. It's where you implement the model into everyday life. So say you're doing something for banking, trying to test for fraud or money laundering, something of that nature, implementing that into the bank's prevalent kind of monitoring system, so that way we can use the model and try to find those that are doing whatever we're looking for. This is actually another part where you do want to maintain observation of your model. Constantly test, make sure it's doing correctly, look at its outputs, make sure that it is giving you exactly what you want it to give you, and then adjust and fine-tune your model as you see fit moving forward. The second question is, explain what needs to be done before you can forecast time series. In other words, what does time series analysis involve? So the first thing you have to do with this is understand the nature of the data. There are some characteristics that it may take on that you really need to understand and you really need to identify before moving forward with forecasting. The first is to understand the nature of the data. Is it stationary or non-stationary? The difference is non-stationary is, it has a trend. Even though the points may go up and down throughout over time, it does move up or down. It does have a trend to it. Stationary, on the other hand, is there is no variance. The trend is neither positive or negative, so while the points may go up and down, the trend line remains pretty much flat. Once you identify that, autocorrelation is another characteristic that a time series may take on. It's basically a systematic pattern value at the same interval. It's the same value at the same time interval. An example of this would be kind of electricity in a household. So when people are sleeping, there's less electricity. So from 10 p.m. to 4 a.m., the points are very low. It's around this time. But when they come home after work, so 5 p.m. to 9 p.m., it's always at a high point. That's autocorrelation. It just means that the values are the same within a given time frame. And then something along those lines is seasonality, which is fluctuation that occurs at intervals. So if you're looking at, let's say, the purchase of suntan lotion during the summer. If you were to map that out by month, what you would see is during the summer months high, and then the winter months it would be low. And that would be the same thing for each year. You would see that trend every year. So understanding those three and kind of applying the characteristics to the time series is very important. Another thing that will be talked about a little later is if the data is non-stationary, kind of deciding whether we do need stationary in order to create a predictive model. Sometimes using these models that we will go over later on, you will need stationary data to kind of ensure that the mean and the variation isn't lost in the noise of the data. But that is for another time. And then the other thing you need to decide on is whether you want to use a simple moving average or a weighted moving average. Basically, a simple moving average is just taking the average without any sort of preference to what point in time it's coming from. Weighted average is you would add a multiplier to more current data to give that more value as opposed to later data. So if you're looking at stocks, you'd want to add a weighted value to the more recent numbers because those are more indicative of what the stocks are going to do now. But to keep in mind, if you are going to add a multiplier of, let's say 1.5 to the front end to the more current data, on the back end you want to do 0.5. You do need to balance it out on both sides. So that's what you need to do to forecast the time series. Okay, so discuss the main principles of data ethics as well as what companies or organizations could do to uphold these principles. That's a great question. The first thing you have to do, and this is something that will occur very frequently, is to ensure that there is no bias present in the collection of the data. This is why when you collect data, you need to be very transparent with how you collected it. You could have a collection bias, which is you only collect it from a certain group of people, thus not being indicative of the entire population. Sample bias, which means you've only gathered, is kind of the same thing as collection, where sample bias is you don't collect information from all different varieties of population. You're only going for a specific one, which is not indicative of the entire population. Exclusion is typically related to kind of like the racial bias or gender bias or sexuality bias, something of that nature, where you omit a group of people from the collection, thereby not being indicative of the entire population. And then there's also measurement. Maybe there's an issue with the algorithm or an issue with the survey that you sent out or the people reading the survey and the data. Maybe maybe they've messed up or had an issue interpreting the data. That could create bias in your data. So you really want to make sure that you understand if there is bias in your data. Another bias you could actually do is the presentation itself. You could create a chart or a graph, I should say, and maybe you set the axes to a way where it doesn't look like things are as bad as they are. You're biasing the data by presenting it in a way that makes it look different than what it's actually telling us. Like I said, you want to make sure that you're transparent with the use of the data, uphold regional privacy laws because they do vary from nation to nation, country to country, state to state, municipality to municipality. There is, especially in the United States, there is no kind of concrete data privacy law like there is in the UK and Europe. So you really want to make sure that you uphold those laws. And then another thing that a company or an organization can do on their level to make sure that they uphold these principles is you create a reporting system for possible bias or ethical misuse. It could be anonymized so that people feel more willing to come forward and say if they have a concern about the ethical issues or privacy issues that are occurring. You could also implement strict bylaws within your company bylaws to enforce data security. Make sure that your employees know that this is a very serious thing and something that you do take very seriously. All right, next question is, imagine you're an analyst at a financial services company and you have some concerns about bias in the way a predictive model was measured. How would you raise your concerns with your manager and make some suggestions for how to avoid measurement bias in the future? Excuse me. So the first thing I would do is just gather specifics on what exactly, to the best of my knowledge, is the concern. Was it a concern with the model and the way it was coded or implemented? Is it on an analyst or a specific auditor, and who was it, if so? Just kind of get as much of the facts as humanly possible, so that way I can come forward with a concrete plan on how to fix it. Excuse me. Then you want to check with your company's procedures and policies to see if they do have actually something that's implemented where you could anonymously or unanonymously report any concerns or ethical issues you may have with the data. Typically, companies that deal with very sensitive data will have something like this implemented, but just make sure that you check the bylaws for that. And if not, go to a senior analyst or somebody in that nature to see what they would do or what they've done in the past for this situation. At the very least, you want to talk to a manager of the project about it, the concern, bring it forward to them, and you really want to make sure that you give a very objective stance on it, data-driven. Yeah, as a data analyst, you should know how to do this. Just be very objective with your statements, fact-based, and definitely do not give forth a feeling of blame or saying that it's their fault or somebody's fault as a whole for this issue. Just say that this is something you found, it's a concern, and then present some ideas on how you would change that or how we should rectify the situation moving forward. Some ways that you can also make sure that this doesn't happen again. Maybe you want to have more eyes on a project. Instead of having 3 analysts, maybe 5 to 7, just so you have more eyes and make sure that it doesn't happen again. Another way you could do is just kind of increase your hiring practices and the standards you use and apply to potential new hires. Make sure that you're getting a better crop and background checks, things like that. Make sure that you're getting the best of the best when you're hiring. And finally, explain the difference between regression and classification models and predictive analysis. When would you use one of these models over the other? This is actually very fascinating to me. A regression model uses quantitative variables to predict future trends. And how it does that is it takes the correlation between a dependent and independent variable and goes, okay, it tends to do this around this time, so at this time in the future, it should be this. It uses past points to predict a future outcome, kind of over a time, usually over a time frame. Classification, on the other hand, predicts a category, a person, a unit, a measure will fall into based on a set of predefined features. So kind of like a decision tree is one of them, like the decision forest, I believe, or the random forest, where if this person is above the age of 35, male, has an income of over 54, then they are more likely to do this. So you're taking a set of predefined characteristics, applying it, and then judging how likely they are to fall to do something else. Kind of some example of these on like who will default on a loan. So if the person hasn't been on the website for 2 months and has an income lower than $30,000, they're more likely to default on a loan than somebody who has been on the website in the past week, has an income of over $80,000, is female, and over the age of 50. So you're taking characteristics, applying them to a unit or a person or a record or an entity and going, how likely are they to do this? So it is another form of future prediction, but it's using more qualitative data than a regression model, which is used quantitative data. And it's for that reason, based on the data type that you're applying this forecasting on, is what would tell you which one to use in what situation. So those are all the interview questions that that were given to me on the task. I hope you enjoyed, and I hope you have a wonderful rest of your day. Thank you.